Let's now discuss what a modulus is. The modulus, r, of a complex number is the distance from the origin to the complex number in the complex plane. So if we had a complex number, a plus bi, if you were to draw a line from that point to the origin, that would be the modulus. If you draw a dotted line from the complex number down to the real axis, you see that we wind up creating a right triangle. So along our real axis, we wind up going a distance of a from the origin to here, since that is our real number. And then the distance from the real axis up to the complex number is b, the value of the imaginary number. So we have a right triangle, and we know the values of two of the sides, a and b. So that will allow us to use trig to solve for our third side, r, or the modulus. But let's say we had the complex number 3 plus 4i. That means this distance along the bottom is 3, the real number, 3. And the distance of this leg is 4, the imaginary number 4. And then you use Pythagorean theorem to solve for r, which we'll get into in a second. But first, I just wanted to also note that the modulus r is also known as the absolute value of the complex number. In case the questions you are given are structured where they're asking you for the absolute value of the complex number, they are referring to the modulus. Throughout this chapter, though, I'll just be referring to it as the modulus, but I just wanted to make sure you were aware of this. So since a right triangle can be created in the complex plane, then the modulus can be calculated using the Pythagorean theorem. The Pythagorean theorem tells that for a right triangle, if we have sides a, b, and c, c being the hypotenuse, then a squared plus b squared would be equal to c squared. And if you're solving for c, the hypotenuse, you'd want to take the square root of both sides, giving you c is equal to the square root of a squared plus b squared. So for the modulus, r will be equal to the square root of a squared plus b squared, the real number and the imaginary number. So we are going to use this formula when solving for the modulus. R is equal to the square root of a squared plus b squared. So let's walk through an example. Let's say you were asked to find the modulus of the complex number 3 plus 4i. Step 1, square the real number, 3. So we'll plug in 3 for a here. So we get 3 squared. And the second step, square the imaginary number, which would be 4. You can leave the I out. And then you want to add the squares together. And then the fourth step, find the square root. So we wind up with r is equal to the square root of 3 squared plus 4 squared, which would be 9 plus 16. 9 plus 16 is equal to 25. And if r is equal to the square root of 25, then that means r is equal to 5. So that is how you would go about finding the modulus. Let's have you try a few practice questions. Question number 1. Find the modulus of -5 plus 2i. Question number 2. Find the modulus of 8 minus 6i. In question number 3, find the modulus of 3 times -4 plus 6i minus 2i. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. So to find the modulus, we'll use the formula r is equal to the square root of a squared plus b squared. So that helps us know that the first step is to square the real number, -5. Then the second step is to square the imaginary number 2. and then you add those squares together, and then find the square root. So that lets us know r is equal to the square root of 25 plus 4. 4 plus 25 is equal to 29. So the answer to question number 1 is r is equal to the square root of 29. Question number 2, we wanted to find the modulus of 8 minus 6i. So step 1, square the real number 8. Step 2, square the imaginary number negative 6. Step 3, add the squares. In step 4, find the square root. So the modulus is equal to the square root of 64 plus 36. 64 plus 36 is equal to 100. And the square root of 100 is equal to 10. So the answer to question number 2 is r is equal to 10. Question number 3. We'll first have to expand and then simplify this expression to a complex number before we are able to plug the real number and the imaginary number into our formula. So the first step is to distribute the 3 to each term in this set of parentheses here. 3 times negative 4 is equal to negative 12. 3 times 6i is positive 18i. We then bring down the negative 2i, and 18i minus 2i gives us 16i. And now we can use negative 12 plus 16i to calculate the modulus. So step 3, square the real number, negative 12. Step 4, square the imaginary number 16. Step 5, you then add the squares and then find the square root. So the modulus is equal to the square root of negative 12 squared, which is 144, plus 16 squared, which is 256. 256 plus 144 is equal to 400. And the square root of 400 is equal to 20. So the modulus for negative 12 plus 16i is equal to 20.